Hi guys, so we're into our third lesson of standard deviation, which is our kind of compare questions that we're going to have a look at. Now you'll notice here in our starter, I've put in capital letters and in red and in bold, put in your notes jotted. It's just so that we can do the starter and then actually use that in our notes for the part B. So I want you to pause here and actually give it a go yourself. And then I'll start going through the question. But if you haven't already done so, then do try it yourself. Just again to double check, like we've done the last time, that you're going along the kind of right tracks. So we've got the cost of a set menu meal in 7 different cafe-style restaurants were as follows. So £14, £17, £13, £14, £11, £19, and £17. So the first thing that we're going to do is work out our mean. As you can see, it's actually even specified in the question. So work out your mean and standard deviation. So we're going to do 14 plus 17 plus 13 and add them all up. And when we do that, we should get 105. And then we want to divide that by how many there are. So 7, so 105 divided by 7. The mean there is £15. Now I've already kind of got my standard deviation table ready to go. So here we've got x, and then all of our values, as I say, I don't personally change them, so it doesn't matter. So we've got 14 take away 15 equals -1, 17 take away 15 equals 2, and so on. I'm not going to continue to write all them down. If it's you, you don't need to write them. I'm just doing it again so we know exactly what we're doing. So 13 take away 15 is -2, 14 take away 15 -1, 11 take away 15, we should get -4, 19 take away 15 is 4, and then 17 take away 15 is 2. Now if we add all them up, we get 0, okay, which is correct. Again, we're looking for that unless we have rounded our mean at all, and we should always get 0 in there, and in general you're not really going to have to round your mean. Normally it comes out as a nice round answer. So then we're going to have a look at our squaring. So -1 squared, positive 1. We should never have any negatives in this last column, okay? Please be careful. 2 squared is 4, 4, 1, 16, 16, and 4. Now, the good thing about standard deviation, the majority of the time, the numbers that we're going to get are normal square numbers. So we don't even need to plot them in our calculators. We should just be able to do them off the top of our head. So then if we add all of those numbers up, 1 plus 4 plus 4 plus 1, and so on all the way down, we should get 46. And then our last part, and this kind of part A, we're going to get S equals, and then we've got our nice formula of sigma of x take x bar all squared over n take away 1. And then remember that sigma of x take x bar all squared is always just our value. It comes out the bottom right hand corner of our table. So then we've got 46 all over 7 take away 1 because we had 7 numbers. And then if we put that in our calculator, we get 2.77. Now it doesn't specify whether to round it to 1 or 2 decimal places, so it doesn't massively matter. Now hopefully you did try it yourself and you can see that you've got the correct answer, at least got the correct process. If you haven't, please send us an email, let us see, and then we can fix whatever small error we've got going. Now continuing on standard deviations, be able to calculate the mean of a set of data. We should have that now, okay, we know what we're doing. Be able to use the formula to calculate standard deviation, yes. And this is where we're up to today. Be able to compare 2 sets of data in sentences. Now, the next slide I'm going to show you is the actual theory and the logic behind these sentences. But I'm going to do the part B, I'm going to do it with us, and I want you to actually copy down the full question, so you'll have to pause it and go through it and then come back to this actual slide. So as I say, at this moment in time, do not copy this in your notes because we've copied out the part A, we've put in the answer to that, and then it wouldn't massively make sense to throw this in, but we will copy it once we've done the next slide. I just actually want to speak through it, so when I'm speaking about it, it makes sense. So we're going to have to write 2 sentences. Our first sentence is comparing our averages. Now the averages we've got, the one that we are speaking about just now is our mean. Other averages we can have is a median, or a mode. Now, probably about, say, 60% of the time, that's a pure bubble, you're going to use the mean. Then the next 37% of the time, even higher than that, probably use the median. And then very, very rarely are we going to use the mode. But let's just, for just now, we're going to focus on the mean. But I'm giving you all these notes for a reason when we do our next kind of part in the statistics. And we have to start when we're comparing our averages with on average. Our second sentence is when we're comparing our standard deviation. And it has to have more or less consistent. Now, these are your parts that's going to help you. So a small standard deviation from the mean indicates that the values are more clustered together or more consistent. Or a large standard deviation from the mean indicates that the values are more spread out or less consistent. Up here, you could also say less spread out. Okay, so the smaller the number, the more consistent. The higher the number, the less consistent. That's really what we're looking at. If it's got a small number, it's more consistent. If it's got a higher number, it's less consistent. Now, the good thing about these questions when it comes up in our exam part A, I've actually not even told you this yet, for a standard deviation question, we get a nice 4 marks. Very easy. Part B, 2 marks. Okay, now obviously I would like you to get 6 out of 6, however, our main focus, let's get this 4 in part A. Part B we'll kind of deal with for just now. So the first thing I'm going to do is write my information that we done in our starters. So the question or the context of part A was cafe style restaurant. So we've got X bar equals, or our mean equals, in that case it was 15, and my standard deviation we worked out as 2.77. Now part B, if we read through it, it says in 7 upmarket restaurants, that's why I put restaurant here, the mean cost of a meal was £22. So I'm going to put in X bar equals 22 and a standard deviation of 2.2. And then using these statistics, compare the profits of the two companies and make two valid comparisons. So we are looking at the X bars together and comparing them, and we're looking at the standard deviations together and comparing them. When we're comparing our X bar, we have to have on average because we're comparing our averages or our means. We also need to have an actual comparison of numbers and context, which is what makes these questions a wee bit more difficult. And then for sentence 2, we're comparing our standard deviations. Again, we need a bit of context, and again, we need a comparison. So looking at these, if we actually were just thinking about it properly, we're talking about prices of a meal, set menu meal. So in a cafe, it was £15. In a restaurant, it was 22. If I was thinking about that out loud, I would be saying the restaurant is more expensive than the cafe. That is an absolutely perfect sentence, as long as we then add in extra parts. Because we're comparing our means, we're going to start on average. And then we say a meal in the restaurant, and apologies for my writing because it's not easy writing in this, is more expensive, and that's our context there because we're speaking about money, so we know we'd use, rather than saying higher or bigger, we can say it being more expensive or less expensive than the cafe. And then this part here, as. Why do we know that? We know that because 22, the number that was there, is bigger. The price of a meal in a cafe is bigger than 15. That is an absolutely perfect first sentence. You could have done it the other way around. It doesn't matter what way around it is. You could have said a meal in the cafe is cheaper than the restaurant because 15 is less than 22. It doesn't matter what way around they are, as long as there's context and as long as there's a comparison. Then we're going to put in the context, so the cost of a meal, and that's what we're speaking about. Now here, our cafe is got a standard deviation of 2.77, which is bigger than 2.2. Now going back to our notes, which you will copy down after this, because that number is bigger, it means it is less consistent. So the cost of a meal in the cafe is less consistent than the restaurant as. We still need that as, and we said, or I said, it's because 2.77 is bigger than 2.2. Now I want you to have a think, what would the opposite sentence of that be? Rather than the cost of a meal in the cafe is less consistent than the restaurant, is 2.77 is greater than 2.2. What would it actually be saying? It would say the cost of a meal in the restaurant, and rather than less consistent, we would use the phrase more consistent because we've got a smaller number. Now, a quick reminder, I know it maybe was a wee smidge confusing, but at this point, I would be copying down all these notes. It's up to you what order you've done your notes, but I think it makes more sense to do one full complete answer and then put in the reason and why. Okay, now we're going to do one more. We'll go through the actual question. Now, I'm just going to do part A, and I'm going to tell you what the mean and the standard deviation are, just because we've done many, many examples of these now, and it takes a wee while for us to go through. And it's mainly the sentences that I want to practice with you just now. So I'll just give you the actual mean, and I'll give you the standard deviation. But you yourself try it. I want you to work it out, write it out freely in your notes. I'm just saving really myself a bit of time. So for my mean, if I add all those numbers up, we're going to have 198 divided by 6 equals 33. Lovely. And we were looking at a set of math test marks for an S3 group of students are shown below. And then my standard deviation, once I go through all my full point, we should eventually get to a stage where we get 410, which is our number that comes out of our table, all divided by 6, take away 1. So my standard deviation is 9.1. Lovely. But again, saving myself a little bit of time. S3's, our mean was 33, and our standard deviation was 9.1. I'm now looking at S4, so I'm going to have X bar, or my mean. If we read through it, we've got a mean of 37, and a standard deviation, so my standard deviation is 8.6. Compare the test marks of the two classes. Again, our first sentence instantly, I would be writing that part down. If you don't write it down on average, we lose a mark, which is the only mark you get for that sentence. So we throw that mark away. Right, so looking at our numbers, here we've got X bars 33, here we've got X bars 37, and we're speaking about test marks. We can speak about higher, lower, better, worse, anything like that. So on average, S4 performed better in the test than S3. And then here we go, we're putting in our numbers, so 37 is bigger than 33. If we put in our numbers, it saves trying to explain the mean is bigger or anything like that. We can just make it nice and clear. There's no ambiguity whatsoever about what we're doing. Why can I not do this? There we go. Okay, now our standard deviations, we were speaking about test marks, and then we want to see which one is more or less consistent. So having a look at our numbers, we've got 9.1 and we've got 8.6. Remember, the lower the number, the more consistent it is. So the group of S4 pupils had more consistent test marks than S3. And again, we're going to put in as, and then it's 8.6 is less than 9.1. Okay, I'll give you a wee second to have a look through that. You can pause it now or you can wait and have a look at the PDF later. Hopefully you can read my writing. If you can't properly, then go back, listen again. What did I say? How did I do it? When it comes to these sentences, the easiest way for me to check that it's right is to be able to look when you hand in your assignment. So I'm not wanting to give you the actual answers to all these questions. I'm going to give you, say all these questions, there's not that many, but it's easier for me to actually check and read through them myself. They feel awkward to do, they feel odd to do. It's a skill we've not really practiced before, but I need you to try them. The only way you're going to be able to improve them is one, to try them yourself, and then me to have a little look at them, or your teacher to have a little look at them and tell you, yes, this part would be right, or yes, that's a perfect sentence, or you could maybe phrase it as this instead. Okay, now the work that I'm going to give you today, it seems like there's quite a lot of questions here. We've got 1, 2, 3, and I think annoyingly I've not put, this should be number 4. The only questions, I say the only ones, but the ones I'm going to get you to do today are 1 and 2. Now notice, you have to work out your standard deviation and your mean for December, and your standard deviation and your mean for March. You have to do 2 for each one, and the same here, 2 for each one, so that you can then write your sentences and you can then do your comparisons. So it's only 1 and 2 that I want you to do today, and then we'll have a look for 3 and 4, the next assignment. Okay, and I hope that's been helpful. If you're not sure, please send me an email.